Hello everybody. Today we are going to look at another program in data structure, and today's program is implementation of stack using linked list. Yeah, that's our experiment number 5, implementation of stack operations such as push, pop and display using linked list. So I've made a program here in code blocks using C++. So stack is last in first out. So whatever comes last will be out first, or you can say first in last out. Whatever comes first will be out last. So in that case, that's the kind of concept we need to use, and we have to implement this concept using linked list. And there are 3 operations that we need to display: push, pop and display. Push is when you have to insert an element inside stack. Pop is when you have to delete or when you have to take out an element from the stack, and display is that you have to display whatever elements are present inside the stack. So you begin by including the header file and then the standard library file. Then I have declared 3 functions here: void push, pop and display, each with return type void. We have created a structure here with the name stack node, and it has 2 structure data, that is data, and it is of integer type. Data is the data that is going to be pushed inside or popped out of or displayed in the stack. So and a link, because in linked list you have one space for the data and the other space for the link or the address of the next node which it is pointing to, and top will be the top point till where the stack element is there. Okay, so we have defined the push function here. Push means inserting element. So when you have to insert the element, top gets incremented whenever an element is inserted. So I've created a new node here. Stack node star temp is equal to new stack node. This is the new operator which is used to create the new node, and I asked the user to enter the data to be inserted, and that is taken as temp data, and temp next is given as top, and top is equal to temp at the end. For pop, if top is equal to null, then we have to display that stack is empty, and you just return. Otherwise, if top is not equal to null, we are doing that because if top is equal to null, that means there are no elements inside stack, right? So if there are no elements inside stack, you cannot take anything out. So if that's not true, then what you have to do is you have to create a temporary node again, and put this temp is equal to top, and top is equal to top next, the next link, and you can just delete temp, and just before deleting, just display it on the screen. So temp data will be displayed. So now I'm going to define the display function. So if top equal to null, again you have to check that, because if stack is empty, you will have no elements to display. So you check that first. If it is true, then you display stack is empty. Otherwise, what you have to do is create a new node temp and put temp is equal to top. You have to do it, then put a while loop, and inside the while loop you put the condition temp not equal to null, because whatever the last element is, that last element's link will be null. So if while temp is not equal to null, until that you just print the data and increment temp, that is temp is equal to temp next. Now you begin by initializing the main, and we have initialized top as null in the very beginning, and then it changes its value again and again as push and pop happens. Then I've given an integer variable here choice for the do while loop. We are going to create a menu driven program here. So inside the do, I've given the menu push, pop and display, and then I've used switch case statement. Inside that I will be passing choice, which will be entered by the user. Case 1 is for push, and then you put break statement, pop, break, display break, and if it is not any of these choices, then you display the default statement. And if the user wants to continue, he or she has to press Y, and that will be taken in this do while loop. I hope you understood. It's really easy. Now let's just see the output. Enter the choice. Suppose I want to push, so 20, and yes, I want to continue. I want to push another element, enter the data to be inserted, that would be 10, and I want to push another element, 67. Okay, yeah, I want to continue. I want to push, so 67 and push. Do you want to continue? Yes. Now I would like to pop out an element, and now I would like it to display. So 67 is popped out, and so 10 and 20 should be displayed. So let's see. Yeah, so that's display. So I hope you understood. It's really simple. It's functioning properly, and that's our program. Thank you. Okay, so we are done with the implementation of stack using linked list. Now another thing that we are going to do is implementation of queue using linked list. So there are operations such as insert, delete and display in queue, and we have to display those operations, that is display the queue using linked list. So I have prepared a program here in C++ using code blocks. Here you begin, a queue is first in first out. Whatever comes first goes out first or gets. For example, if you are standing in a queue for a movie ticket or something, then who goes first will get the ticket first. So that's the concept of queue. So you begin by including the standard library file and header files, and I've declared three functions here, each with return type void, enqueue, dequeue and display. Enqueue is the name, proper name for inserting an element inside queue, and dequeue is for deleting an element inside queue, and display is for displaying the elements present inside the queue. Okay, here also we will create a structure, and the name will be node, and here inside we have variables such as int info, which will be the data which is going to be entered, and I've created a link here, that's the next link, which will hold the address of the next node, right? And we have two variables here, rear and front. Since in queue there are two variables, rear and front, so insertion and deletion can happen from both ends. So I am defining the function enqueue. I've declared an integer variable data. So this will be the data which is going to be inserted inside the queue. I will create a new node, that's node start temp equal to new node using the new operator. And now I ask the user to enter the data, and I'll store the data using cn. Now we are going to store the data inside temp, the new node which we created. So temp info is equal to data, and temp next is equal to null, because now it is not pointing to any other element. As soon as it points to any other element, we will have to change the link. If front is equal to null, then put front is equal to temp. That is, if there are no elements, then the element which we are going to insert will be the very first element. In that case, front will become equal to temp. Else, what you have to do is rear next is equal to temp. Okay, the rear's next will be equal to temp, and after that you just put rear is equal to temp. Okay, so that's the enqueue function. Now moving on to the dequeue function. In dequeue function, you create a new node using the new operator. First you have to check if the queue is empty or not, because if it is empty, what are you going to pop out, what are you going to delete? So if front is equal to null, then you show a message stating queue is empty. Else put temp is equal to front, and front is equal to front next, and just display the data that you deleted, and just finally delete the temporary node which we created using the delete operator. Now we are going to define the display function. In that also you create a new node using new operator, and then you put temp is equal to front, and in this also you have to check if the node if the queue is empty or not, because if it is empty you will have no elements to display. So if front is equal to null, you have to pop out a message stating queue is empty. Else, while temp is not equal to null, if temp will become null only at the last element. So we will have to traverse to the last element. For that we are putting this condition. So you print the data temp info and just keep on moving temp. That is temp is equal to temp next. As soon as this condition becomes true, the loop will stop. Now we begin by initializing main. So the two variables rear and front, they initialize to null in the beginning, and then we have given a menu driven program here. So for that we have two variables choice and ch declared here. Inside the menu, inside the do while loop, I've given menu with three options, enqueue, dequeue and display, and I'll be taking the choice from the user, and first choice is enqueue and then break, case 2 is dequeue and case 3 is display. And if the user doesn't input any of these choices, then we will display the default statement, that is invalid input, try again. Then if the user wants to continue, he will press Y, and then this do while loop will take care of it. I hope you understood. Now we'll just try to see the output. Okay, so I will first like to insert something. I would like to insert another element 20, another maybe 45. And now I would like it to display 21, 20, 45, because whatever is inserted first is displayed first. I would like to continue. This time I would like to dequeue an element, so 21 is dequeued. Now I would like to display it again. So that's great. I hope you understood. It's really easy. Thank you.